smoke. That's why I got it for cheap. I know. I think so on the dash. Just one? I don't know. I don't really care. I don't give a hoot. So I went to Canadian Tire and I tried to find like all kinds of odor eliminating stuff. Just a lot of elbow grease. Found some weird stuff in there, like eggshells kind of in the, yeah, this thing was like a mess. Anyways, it was really cheap, so. It'll be my little pet project. Okay, here we go. Are we ready? Let's do some review because it was a while ago that we met last. So just some quick review. We talked about expanding, right? Expanding an expression. Expanding, we say, is basically where we break out the brackets, right? And we expand the whole thing. So I'm going to say break out the brackets. That's when we're expanding things. We talked about some rules there, right? But you have to, you have a common multiple. You have to pull it inside the brackets, right, to expand it and get rid of the actual brackets. And then we talked about factoring, okay, which is basically expanding in reverse. Okay. Where we collect common multiples to create a condensed equation, right? So expanding in reverse to create a condensed equation. Then we moved on to talking about solving systems of equations. We only used by substitution. Okay. So solving systems of equations systems, I guess, potentially plural, of equations by substitution. And I did a quick little play-by-play of how we would do it by elimination. And if you're interested in it, then the textbook goes through and tells you how to do it, but I'll only use substitution. I think one method is plenty. So we don't need to know two ways to do the same thing. Okay. So remember, that's where I have something like 2x plus y equals 4, and then 3x plus 1/2 y is 2, right? And I ask you to solve the system. Right. We'll come back to that. So we're not going to review it now because we're going to work more on it today. Okay. Then we moved on briefly to talk about taxes and other proportions and percentages. Proportions and percentages. I was brief in that section on purpose because we kind of know how to deal with that stuff from before. So whatever you want to do naturally, that's good. And again, we'll come back to it next chapter. So just a quick introduction last day, and that's all we did. So that's kind of what we did last day. Any questions about that before we get started on today? No? All right. Let's do it. So today we're going to start 2.1. So chapter 2, section 2.1, linear functions and graphing. let's do a quick little review. So the equation of a straight line, right? If I say y equals mx plus b, that probably rings some sort of bell, right? So the equation of a straight line, would be in the form of y equals mx plus b. Okay. Or you might have seen something like y equals ax plus b, or even y equals a sub 0 x plus a sub 1. Can do that. Right. But you've probably only seen y equals mx plus b. Right. But the setup for these are the same, right? We have one variable attached to the x, right? So whatever variable is attached to the x, that's your slope, right? And then you have one variable that's on its own, right? And that's going to be your intercept. Okay, so these are optional, just to show you what's going on. Okay, so we have m is going to be your slope, right? In general, whatever's attached to the x, that's your slope. And whatever's on its own, the b, is the intercept. Okay. So we have to keep track of those. Okay. I'll just write down here where m is the slope. Right. In brackets, whatever value is attached to the x. Whatever value is attached to the x. Where b, right, b in this case is the one on its own, right? So that's the intercept. Okay. So it's going to be whatever value is on its own And just another note, right? The intercept, what is the intercept? The intercept is where the line crosses the y-axis, right? So you've got your x and your y-axis, right? So where the line crosses the y-axis, that's your intercept. Okay? So where the line, we're only talking straight lines here, where the line crosses the y-axis. Okay. Which also means that x, it's the point where x is 0. Okay. We visualize it. We have our x-axis and our y-axis. Right, you'll want to keep track of those. I will assume that you know those. Did I tell you guys how one girl told me she remembers the x-axis? I don't think so yet. Anyways, so for me, they're kind of second nature, so I just assume that you know which is the x-axis and which is the y-axis, right? But if you're having a hard time remembering, I had one girl tell me, oh, I just imagine this little cartoon X, and he's going, no, because the beam just kind of fell on him. So it makes no, that's the x-axis. And now you'll never forget. I hope. Okay, so so that's your x-axis, your y-axis, who cares? It's the other one, right? Okay, so at this point here, right, we're at 0, 0. which means that this must be where x equals 0. Right? So here at x equals 0, that's where we're going to cross the y-axis. So if we have some kind of random line here, just wait for it to go straight there. Who cares what the point is, right? But this is your intercept. Okay. And that's where x equals 0. Okay. We kind of touched on this last day, right? Where I said, okay, any equation where you just have an x and you just have a y, or you can kind of consolidate and make just an x and just a y as your variables, right? Collect like terms and that kind of stuff. You can rearrange it to the form of y equals mx plus b, right? You can just solve it so that the y is on the one side and then the x is on the other side with the other stuff, right? So that will make a straight line. Okay. So whenever we have an equation, sorry, I know it's boring, but I'll sit down, see if my writing on this angle is a little tricky. Flared up my wrist a little bit, which is not ideal. Work safe, guys. So a little bit boring. Hey, I'm still here. But with a little bit of luck, my writing will be a little bit nicer. So whenever we have an equation with just x and y as our variables, we can rearrange it into the form of y equals mx plus b. We can rearrange it into the form of y equals mx plus b. Right. I'll put in brackets a straight line. So that's good. And so last day we solved systems of equations and we didn't graph these lines, but now we're going to start graphing these lines. And so how do we graph a line? Let's do it. How do we graph straight lines? Okay. I'll say given a linear equation, hey, a linear equation, well, no big stretch here, right? Y equals mx plus b, I'm saying that is a straight line, right? So we can also call it a linear equation, right? It's an equation of a straight line, linear equation. Okay, so given a linear equation, y equals mx plus b, okay. For example, y equals, let's say 2x plus 1, keep it simple. Okay. We can graph this if we just find 2 points on a line, right? So any straight line, you only need to know 2 points on that line, right? You plot those 2 points, and then you take a straight edge. There's lots around, right? And you connect those two, extend the line, and it goes on forever and ever and ever, right? So to draw a straight line, you really only need 2 points, right? So given a linear equation, to graph this, we need to find 2 points on the line. Okay. Oh, comma. Then we use a straight edge to connect them. Okay. So I like to have a routine that I follow. So for me, if the equation isn't in the form of y equals mx plus b, we're going to start there, right? Solve for y. Okay? But for now, we have y equals 2x plus 1. So if I have to graph this, then I'd like to start by making a table of just x values on one side and then solving for the y values, right? Because to plot these points, we need the x and the y coordinates, and then we can go from there. Okay, so I'd say step 1 is make a table of at least 2 values of x, and then we'll solve for y. We only need 2 points. If you want to do 3 points, go for it. You'll find they're on the exact same line. Right? So I only do 2. Step 2 is going to be to find the corresponding y values. Okay. So you've picked your x's strategically, okay, and then you solve for the y's that link up with that. And then you're going to plot those points. So plot the xy coordinates the xy coordinates are also called ordered pairs. If you're reading the textbook and you come across ordered pairs, they're the same thing on a graph. And then your last step is to connect the dots and extend the line. So connect the points and extend the line. So for y equals, I don't know, something simple, I had 2x plus 1. Right. First thing I would do is make a table of x values and y values. And I'm only going to do 2 values. I'm not an overachiever. Not trying to be a hero here. Okay. So my go-to x value that I start with is just x equals 0. Right? That's easy to solve for. Let x be 0. You can pick any value of x that you want. Right? So why not make it something that it's easy to solve for? Right? When x is 0, y equals 2x plus 1 is going to be 2 times 0 plus 1, which is just going to be 1. Right? Something easy like that, you don't have to show your work, but it's a good idea if you have a bigger equation, right? We're obviously going to move into bigger equations. Then it's best to show your work in case something gets lost. Right? And what's another easy value of x to deal with? I'm going to pick, thank you. So we've already got our favorites, favorite x and x, I guess. So 2 times 1 plus 1 is 3. Okay. Just as a little note here, right? In the form of x, y, right, ordered pairs, this first point would be 0, 1, and the second point, right, would be 1, 3. Just as a heads up. Okay. So we can graph this. We set up our x-axis and our y-axis. Oh, I should have gone maybe a little bit. I need more room. Why do I need more room? Because for my 2 points, right, my y goes as high as 3, so I have to have room for at least 3 if I'm using a line for each unit, then, right, 1, 2, 3. And I'll make them kind of the same, 1, 2, 3. My x-axis, my y-axis. On the test, I'll give you the axes already, right? So you don't have to make them. For a simple one like this, it's easy to do, right? But we get into trickier stuff, right? The method stays the same, but takes longer to figure out your axes. All right, so let's plot these points. And so we have a point at 0, 1, so where x is 0 and y is 1. Right. I'll do a little darker green. 0, 1, that's this point here. Can you see that? I'll keep it for now. And then our next point was when x is 1 and y is 3. So somewhere around here is our 1, 3 point. The color I picked was a little light. All right, here we go. So we've plotted our points. Now to draw this line, we just need to connect these two. And I just use any straight edge. Often I'll just kind of bend the paper over a bit, follow along. All right. So here, I'm just gonna connect these and go. Without the little wisps on the end. Those are accidents. Okay. And then it just keeps going and going and going forever. So this is the graph of y equals 2x plus 1. We did it. Cool. Any questions about that one? All right, so let's do an example. Hey, got a little chatty in the back there. Sketch the graph of 4x plus 5y equals 2. Okay. So I'll give you just a minute to kind of get going on that, and then I'll check in to make sure we're all on the same page. You can, yeah. Yeah. Okay. So this is one of those scenarios, right? We have an x and a y. We can rearrange it in the form of y equals mx plus b, right? So first thing we're going to do is solve for y to get this in the form of y equals mx plus b. Just to sketch it, we don't actually need it, right? We could just go straight from here, but it's just easier later on if we just get in the habit of just rearranging it into y equals mx plus b. So we have something like 4x plus 5y equals 2. Solving for y on the one side, right, we have to subtract 4x from both sides. So 5y is 2 minus 4x. So then y is 2 minus 4x. We have to divide both sides by 5. Right. We don't like to have that common denominator, so we can split this up. This is the same, this is the same as saying y equals 2 divided by 5 minus 4x over 5. Right, that's kind of the reverse of what we were doing the other day. Right, to subtract two fractions, we had to have the common denominator. Right, if we have a common denominator, we can split them up and have them as two separate terms. Right, so that's all we're doing here. And now, even though we have a kind of a nastier looking thing here, right, our slope is negative 4 over 5 and our intercept is 2 over 5. Right? So if we want, or we can write y is negative 4 over 5x plus 2 over 5. Right? Where this is our slope and 2 over 5 is our intercept. So a little bit nastier than our first example, right? But we can deal with it. So the whole goal was to sketch this thing, right? We need to find 2 points on this line. So I'm going to set up my little table here of x and y values. I'm going to remind myself that y equals negative 4 over 5 times x plus 2 over 5. Yes, unless you have repeatings or anything like that, then you want to keep the fraction. Or how about this trick? We pick values of x that kind of make the fractions go away. Right? I know. Let's stick to our default though. I still like having x equals 0. It's just nice. It's easy to solve for. Right? So when x is 0, we have negative 4 over 5 times 0 plus 2 over 5. It's just 2 over 5. Or 0.4 if you convert it to a decimal. So you can check it, right? And if it's a nice decimal, you can use it. Right? If it's a nasty decimal, then stick with your fractions. Yeah. How about what would make our fractions kind of go away or look a little bit better? X equals 5 would do that, right? Because if we use x equals 5, we get negative 4 over 5 times 5, right? Plus 2 over 5. This one's going to need a little bit more work, right? Negative 4 over 5 times 5 is just going to end up being negative 4 plus 2 over 5, which we decided was 0.4. You can keep it as a fraction if you want. But because we already know that it's a nice decimal, let's just work with that, right? It's easier to look at. Negative 4 plus 0.4 makes negative 3.6. Cool. So just as ordered pairs, right, we've got 0 and 0.4 and 5 and negative 3.6. That's point. Okay. Oh, slightly uglier to plot, right? But like I said, I'll give you the axes on the test, so, or something that's easy to number. Okay. Let's just do a little. The problem is that now we've got negative 3.6 for our y, right? So we need to go down to negative 3.6 for our y's and over to as far as 5 for our x's, and a little bit beyond if we want. Okay. And so let's start with our first point. That's when x equals 0, then y is 0.4. So let's say each of these is 1, negative 1, negative 2, negative 3. Oops, should have kept going. Negative 4. And then 1, 2, 3, 4, 5. Got a little unevenly spaced, but you get the idea. Okay. So 0 and 0.4, x is 0, y is 0.4. Let's put it somewhere here, right? If this is 1, then this must be 0 and 0.4. For the 5 and negative 3.6, let's find negative 3.6. It would be somewhere, I don't know, somewhere around here. Once I move too far away from the axes, right, it's nice to have like a guideline, right? And x is 5. So here we're at 5, negative 3.6. So now if we take our straight edge, whatever it is, and just kind of connect the dots, sort of. It's a little off, but oh well, doesn't matter. I'd say it's still pretty good. Then this, now we've sketched the line. Oh, hello. We've sketched the line of y equals negative 4 over 5x plus 2 over 5. later we'll start talking about, okay, well, everything has to be greater than this equation, right? Meaning everything has to be above this line, right? So then I would only be talking about this area here, right? So we'll move into that later, but I'll undo that for now. Okay. So we'll start working with inequalities on this line, right? Has to be greater than this or less than this. But for now, we just need to know how to sketch lines. Okay. Just as a general note, right, if you have something, your xy's here, this is a negative slope. And if you have something like this, you have a positive slope. Okay. We knew it was going to be a downward slope because our slope is negative 4 over 5, right? That's negative, so we have to have a negative slope. Okay. So I'll just highlight here. That we have a negative slope, negative 4 over 5. Any questions about that? Cool. Okay, so we'll parking lot that for a little bit. We're going to start talking about functions, right? Y equals negative 4 over 5x plus 2, 5. That is a function, right? Y is a function of x because it takes some value of x and gives you some output value. Okay. And so let's just talk about functions. Right. So functions take a value of x usually. So of x and return an output value y or f of x. I guess I didn't turn off all my notifications. I also got a snap this morning and I didn't turn those off either. But I don't get a lot of snaps. So. For a while, I wanted to like incorporate, like do like little Snapchat lectures. It's like, hey guys, remember this? yeah, just like quick little review things throughout the day. It'd be mandatory. But it just doesn't work that way. So when I write f of x, right, I want you to read f of x as f of x. Right. Okay. So we can write y equals f of x, right? Y is a function of x. So y and f of x are going to be interchangeable. Okay. Is going to be the same as mx plus b. Oh yeah.
Why is the brackets around the x?
Because it's f of x. So yeah. So it's function notation, and we'll do a quick example of it. But yeah. So let's just say, I'll just make a note here, right, that y and f of x, they're interchangeable, right? Whatever looks nicest is the one we use. Okay. So y and f of x are interchangeable, okay, as y requires a value of x to be solved, right? We have to put in some value of x to solve for y. As y requires a value of x to be solved. Okay. For example, if I tell you that f of x is 2x plus 1, right? Using function notation, I can ask you to find f of 2. Right? Solve the function when x is 2. Is what that means. So f of 2 would be 2 times 2 plus 1. Skip straight to 5. I shouldn't. 2 times 2 is 4 plus 1. It was only one line. Okay. So then if we have something like this, right, our x value or y values, okay, the function, right, takes some value of x equal to 2, right, and returns that y must be, let's say, 5 here. This point is at x equals 2, and the y value technically is going to be f of 2, right? The function evaluated at 2. Okay. Then we've got our straight line. Okay. Because here I'll make a note, f of 2 is 5. So that's just how functions work, right? But if you're able to look at this and say, okay, I tell you what f of x is, and then I tell you find f of 2, and you know just to put in a value of 2 in for x and solve for f of 2 or y, right? Then that's good. Then you don't need my little graphic, right? I'm just showing you that we put in x equals 2 and it returns the function. Right? Okay. Questions, comments, concerns? Example 57. If I say let f of x be 3x plus 1, find f of 10 and f of negative 5. F of 10, right, is going to be, I'll start out 3x plus 1. I like to always start out with the plane equation and then I plug in my values after. So 3, and I know that x has to be 10 plus 1. 30 plus 1 is 31. So f of 10 is 31. Okay. How about f of -5? Again, plain equation, 3x plus 1. 3 times -5 now, plus 1. 3 times -5 is -15, plus 1, -14. Okay. Cool. Notice how for each equation, I stack all my equal signs, right? So that's what I want to see. I know it wastes paper, but it's the proper way to do things. So, too bad. Okay. Cool. Kind of more relevant example, right? We can use f of x and that's fine, right? But let's look at example 60, where I tell you that the profit of x, right? So here we have a profit function taking some value of x, probably how many units you sold, right? Or how many hours you've worked or whatever, right? That you're making a profit off of, okay? Has this function. So 45x minus 725. Okay. And later in the course, we'll look at how do we develop these profit functions, but for now, I'm just going to give them to you. Right? So, let's say part A. If I ask you, what is the profit when x is 50? X might be, let's say x is the number of things you've sold. Sounds reasonable. So if you've sold 50 things, then you want to find the profit using the same notation, right? The profit of 50, right? F of x, profit of 50 is going to be, and I write my plain equation, 45x minus 725. Now 45 times 50 minus 725. Okay. 45 times 50, I have 2250 minus 725. Bless you. Puts me at 1525. So if I sell 50 things, I make a profit of $1,525. That's great. You can throw a dollar sign on there just for kicks if you want. But like I said, I'm not going to be too picky. Okay. What if I asked you, oh, I guess it's, I'll just change it. How many items do you have to sell if you have to make 0 profit, right? There's costs associated with production, right? And so that's the 725. So you have to make at least 725 to hit that 0 profit mark, right? And so that's interesting to know, how many things do I have to sell in order to start even making a profit, right? And so how many items do we need to sell to earn $0 profit? Okay. So from before, we know that the profit of x, I'll just copy it down here, was 45x minus 725. And so now I want to know, what does the x have to be in order to make the profit 0? Right? And so now I'm going to replace this profit of x with 0, right? Because I'm forcing the profit to be 0. And then I'm going to solve for x. 45x minus 725. Just make it here, solve for x. Okay. All right, not too bad. We can add, so we want to get x on its own, right? I just kind of pretend to hold it steady, right? I hold the x and then I try to move everything else around it over. Okay. And so I'm going to add 725 to both sides. So I get 725 is 45x. Right, and then I have to divide both sides by 45. But remember, I like to do that switcheroo where I put the x on the left-hand side because that's what I'm solving for. But nothing really changes. So x is 725 over 45. Perfect. I think repeating, right? So what does that mean? Well, it means you have to make more than, or you have to sell more than 16 items, right? 16 items just doesn't quite get you there, right? You're slightly at a negative profit. It's costing you money. But if you get 17 items out there, then you're past 0. Right? So the question was, how many items do we need to sell to earn 0 profit? We need to sell at least 17 items. I'll put in brackets here, 16.11. We can't actually sell 0.11 of an item. So it'll depend on the context, right, if you round up or down. So we have to round up to 17, right, in order to make slightly more than $0 in profit. Right, we won't be able to make exactly 0, and that's okay. Right? Or if you wanted to say we need to sell at least 16 items to make close to 0 in profit, that's fine too. Right? So a lot of my marking is going to be, do you know, basically, do you know what you're talking about, right? I don't care so much about, you know, all your values. I kind of follow through and make sure that what you're doing makes sense, right? So I'm marking more on conceptual than just the pure math, right? Obviously, if the math is right, it's easy to mark, right? But if something looks off, then I follow through, and if you're justifying it at the end, like I've done here, right? We need to sell at least 17. So I'm recognizing that I can't sell 0.11 of an item, right? And then I say, well, if I sell 17, I'm making slightly more than 0 profit. Right? If you went the 16 route, that's fine too. Then you would have to highlight that you would be making slightly negative profit, right? Less than 0. Okay? So as long as you're justifying what you're saying, then you're okay. Okay. As long as it makes sense. So how about C? How many items do we need to sell to make at least $1,000 in profit? How many items do we need to sell to make at least $1,000 in profit? So this is a similar scenario, right? Except now I'm saying, well, we have to make at least $1,000, right? So we can't have slightly less than 1,000. So we remember our profit function again. Our profit of x was 45x minus 725. Just always writing out our formula that we're working with, fill it in, solve it. Okay. So now we're saying that our profit has to be at least $1,000. Right. And we have to solve for x again. Right. So the exact same type of question, just we've changed the amount of the profit. Okay. So again, to solve for x, right, we have to add 725 to both sides. So we get 1725 is 45x. Dividing both sides by 45, we get 1725, sorry, over 45. So x is roughly 38.33. You don't have to do the approximately equal sign, right? That's the squiggly equals. Whenever you're rounding or capping repeat decimals, technically you're approximating, so you use the approximately equal to. Not something that I'm going to be looking for, but if you want to be proper, I can appreciate that. Yeah. I'll make a little note here. Approximately equal to. Now that I've talked about it, I should make a clean one. Squiggly equals. Right. So to have a profit of at least 1,000, right? I can't just sell 38 because that's going to be, we assume that we're going to make more profit the more items we sell, right? So if I only sell 38, that's slightly less than 1,000, right? Because to get exactly 1,000, I would have to sell 38.33, 3333333, right? So we're going to have to sell at least 39 items to make at least $1,000 in profit. Okay, so we would need to sell at least 39 items to make at least $1,000 in profit. So it's kind of a fun example, right? Profit, fun. Did you guys ever watch that show, The Prophet? It's really good. I think it was on A&E. Oh, does anyone play HQ here? It was consuming my life for a little bit, like trivia. I never got to the end, but you win money. All right. So when we're talking about functions, we need to talk about the domain and the range of these functions, mostly because there's some illegal math that could come up, right? And so let's talk about the domain. The domain of a function is all possible values of x, meaning it excludes all the illegal math moves that we could make. Okay. So the domain of a function is all possible values of x. So if a value of x results in illegal math, I'll put quotes around it. Illegal math, that's what I call it. Things you can't do. It is not in the domain, right? We can't use it because it yields illegal math, right? So what are the two illegal math moves that we need to keep an eye out for? There's really only two that we need to be aware of for this course. Okay. The first one being we cannot divide by 0, right? So if you get to a point where you're trying to divide by 0, it just can't be done, right? You can try it on your calculator. It's not going to do it. Okay. So 1 divided by 0, error 1. Right? Just can't be done. So division by 0, that's a big illegal math move. Okay. And the second one, right, is if we ever try to take the square root of a negative number, we can't do that. So we can't take the square root of a negative number. So if you find yourself trying to take the square root of a negative number, technically that puts you into imaginary numbers, right? The square root of -1. We're obviously not dealing with that. It's like way later math courses, okay? You've probably just done something wrong, right? We won't be trying to take square roots of negative numbers. Okay? So if you get there and you're thinking, oh no, I have to take the square root of a negative number, that's not in the domain. I know that's what you would think. Then you backtrack and think, where did I go wrong here? Right, check your work. Okay. So if you have an x value where it makes you divide by 0, right? Usually x equals 0, can't be done. If it's in the denominator, or where an x yields the square root of a negative number in your function, then those x's are not in your domain. Okay. We can talk about the range. The range depends on your domain, right? Because it's going to be all the possible output values of y. Okay. So the range of a function is all possible output values of y. Okay. So it's just looking at all your x's in your domain, right? All your legal x's, then all those possible output values of y are your range. Okay, so your domain and range. Okay. Those are just things that we need to keep an eye out for. It's not going to be super important because I'll always kind of, all the x's will be in the domain usually, and all the y's will be in the range, right? That's your default. Okay. But it might come up that I say, oh, x equals 1 isn't in the domain because of this, right? So you need to know what it is. Okay. But that's it. Let's do example 63. Okay. If we have a function, that looks like the future value is the present value times 1 I think the textbook actually has PV there. Ah, fine. I'll change it. PV, Puerto Vallarta. Times 1 plus I, lowercase I, to the power of n. Right? Once we have our formula sheets, and when we need them, I'll bring them in, but I don't want to give you papers until you need them, right? And so you'll see this formula on there, right? So it is one that we're going to work with, right? But it's just a function, okay? And we have 4 variables, right? The future value, the present value, the interest rate, and n is the number of years that we're investing this thing, okay, at its simplest form. Okay. So where the future FV, right, is the future value, PV is the present value, lowercase I in its simplest form is just the yearly interest rate. Yearly interest rate. And n, lowercase n in this case, is going to be the number of years invested. So how these are going to go is you're going to deposit some amount, that's your present value, right? And then at some interest rate, it sits there for some amount of time. And at the end of it, you have some future value, right? And so we're going to work on, okay, how do we calculate the future value, the present value? So we can calculate all of these 4 terms as long as we have the other 3, right? So, quick little example here. If an investor invests $1,500 at a rate of, let's say, 6% per year, what is the value of the investment after 7 years? Okay. So we'll write out our general equation, right, from up here. Okay. The future value is the present value times 1 plus I to the power of n. So in this case, right, we want to solve for our future value, right, because we know the initial amount invested, right, the 1,500. So that's going to be your present value, 1,500. That's your present value. Okay. Multiply that by 1 plus the interest rate. I remember we said was the yearly interest rate. It's 6% per year. Okay. But we also said last day that when we're dealing with percentages, right, we have to convert it to the decimal, right? So 6%, that's 0.06. So plus 0.06 to the power of n. N, we said, was the number of years invested. Perfect. So I just want to make a note here, right, that the 0.06, the 6%, must be in decimal form. So going back to our bed mass, right, we have brackets. So let's deal with those brackets first. So we leave the 1500 on the outside. Yes.
6. The power, it should be 6.
Oh, in the textbook, yeah, but I changed it to 7 because I didn't like to have the 6% in 6 years. I like to, but thank you. Yeah. Yeah, good call. Oh, I did change the textbook or the question to 7 years from 6 years, just so you can see where the years and the percentage go. Otherwise, they would be the same. But thank you. Yeah, I meant to say that. So in the brackets, right, we have 1.06 to the power of 7. Right? Only the 1.06 is to the power of 7. So now we've dealt with our brackets. Next thing, exponents. We have exponents. So we're going to have 1500 times 1.06 to the power of 7. Do you guys remember how to do it on your calculator? So 1.06 and then the y to the x button. It won't do anything on here, right? But then we can hit 7 equals, and you should get 1.50363025.9. Remember, as long as you're keeping all your decimal places in here, that's good. You don't have to write out all your decimals. I just wanted to, in case you're, going through your notes at home, you want to make sure that you're getting the same thing. All right. And then that, now we can multiply by the 1500, so times 1500. We get $2,255 and 44538 pennies, or roughly $2,255 and 45 pennies, right? Rounding properly, because the 4 is followed by 5. 5 and above, we have to round up. Right? Optional. I'll do it, but you don't have to. If you just do equal sign, it's fine. Cool. So this guy invested 1,500. He's getting 6% annually, right, per year for 7 years. And so his future value, $2,255.45. It's pretty good. Right. Any questions about that one? Okay. No questions about that one? No? Cool. All right. We'll change gears a little bit, heading into section 2.2. Supply and demand economics. I am not going to talk a whole lot about the actual supply and demand curves, right? I'm just going to talk about them briefly, what we need to know, right? But like I said last day, our whole goal is to find the point of intersection, right? That's our equilibrium point, and that's what you need out of this course to take into your other courses, right? Where they'll actually talk about supply and demand, but that's economics. That's not really business math, right? So the textbook does talk about it more, but in the interest of time, I'm not going to. And also, I'm not very good at it, and that's okay. So on a supply and demand curve, which you've probably seen, at some point. We've got the price on the y-axis, right? And on the x-axis, we have our quantity. We supply some quantity at some price, or we demand some quantity at some price, right? And so in general, demand curves, right, denoted by a D, demand curves has a negative slope. Demand curves have a negative slope. Okay. Right? If the price is high, we demand less quantity, right? If the price is low, we want lots of it, right? High quantity. Okay. So one thing to remember, our x-axis, right? That's going to be our quantity, and our y-axis is going to be the price. Okay. And so for our supply curve, right? Now we've got price and quantity here. Is going to be positive, right? Kind of the other way around. If the price is low, we don't want to sell too many. And if the price is high, then we want to sell lots. Supply curves have a positive slope. Putting these two on the same graph, right, like we talked about, right, they would have some point of intersection, right? That's where the supply and the demand curve are both satisfied, right? So that's our equilibrium point. The point of equilibrium will be the point of intersection. Price and quantity. P or Q? What's a Q? Sorry. So we have this general supply curve and a general demand curve. Oh, I should make them nicer, shouldn't I? No. Whatever. Where they intersect, right? That's your equilibrium. Okay. So at this point, right, we have some quantity of the equilibrium. That's a Q again, sorry. And some price of the equilibrium. So I'm just writing P and then subscript equilibrium or EQ, and then Q, EQ. This one got messy again, so I'm writing too small. Right. So the equilibrium point is at some Q EQ comma P equilibrium. Okay. So the supply and demand curves, they're both straight lines, right? They're linear equations. So we can, if we know their formulas, right, or their equations, then we can solve the system to find P at the equilibrium point and the Q at the equilibrium point. So since S and D, right, the supply and demand curves, will be linear equations, we can solve the system of equations, to find the point of equilibrium. So it would be set up a little bit differently than what we've been seeing, but nothing too crazy, right? Nothing's really changing. If we have a look at example, or just an example, find the point of equilibrium when, and I'm going to tell you, the supply curve has the equation Q equals 2P. Right, that's our first line. Okay. Q, right, is taking the place of X, and P is taking the place of Y. And the demand curve is Q is 10 minus 3P. I'll just make a quick little note here. Q is taking the place of X, and P is taking the place of Y. And I'm just stealing that from our graph here, right? Prices on the y-axis, quantities on the x-axis. So it's the exact same thing, just a little bit different. So we want to find the point of equilibrium. So we solved systems of equations last day, and we said, okay, I'm going to solve for one variable in one of the equations, and then I'm going to substitute that into the other equation. Right? What's nice here in this little example is they're both already solved for Q. Right? So I have both of them in terms of Q, so I'm just going to take one of the Q's, sneak it in for the other Q, basically set them equal to each other, solve for P, and then I can backtrack and solve for Q. So we can say something like this: Q equals 2P, and Q equals 10 minus 3P. I'm going to call this equation 1 and this equation 2. Equation 1 or equation 2, it doesn't matter, right? One's just going to go in place of the other. So, but following the same structure, right? I'm going to substitute equation 1 into equation 2 to solve for P. Well, equation 1 into equation 2, or equation 2 into equation 1 doesn't make much difference. Right? So we have 2P is 10 minus 3p. Solving for p, right, we want to collect like terms, so we want to get our p's on one side and all our numbers on the other side. So I like to add stuff, right? I don't like negatives too much. And so I'm going to move my negative 3p over to the left-hand side, right, by adding 3p to both sides. So I'm going to do 2p plus 3p equals 10, which means I have 5p equals 10. So p must just be 10 divided by 5, or p is just 2. So at the point of equilibrium, right, the price of whatever product has to be 2, right, 2 units. Okay. So now, following the same structure as we did before, we're going to substitute p equals 2 into equation 1 or equation 2 if you want to solve for q. So from equation 1, right, we had q equals 2p. I'm picking that one. It's easiest. Although they're both pretty easy. So q must be 2 times p must be 2, right? And so q has to be 4. You can check it in the other equation for q, right? Equation 2, if we put in p equals 2, we get 10 minus 3 times 2. 10 minus 6 is 4 again, right? So it doesn't matter which one you use. And you can check your answers, right? Check that p equals 2 and q equals 4 satisfies both of those equations, right? But then we're going to say, therefore, the point of equilibrium is when the quantity is 4 and the price is 2. Right? That's our only equilibrium point. Right? For 2 straight lines, they only ever cross once. Right? So it's the only solution to this supply and demand curve combo. Okay. Any questions with that? Cool. Oof. Ending way early, but that's all I've got. So hopefully no one minds. If there aren't any questions, then see you on Wednesday.